Hi, this is Map 1340, and this video is going to be over section 3.2, and it's part 2 of 3.2. Now, we looked at zeros and the leading coefficients to determine the end behavior of the graphs in the last time. This is going to be more on zeros, but it's also going to be on some other features of polynomials. Eventually, we're going to be able to break polynomials down to high degrees into the factors and find the exact real zeros. But there's other features we want to look at as well. So if we look at these by graphing, we're going to do that first. So f of x equals 6x cubed minus 7x squared minus 20x. We can see what the graph looks like. We can adjust the window if we need to, but we can see a lot of this. You know what? I do want to adjust the window. See what has there, negative 10, 10, like 40, 40. Sometimes adjusting it manually allows you to see a lot better. Now we can see the 3 intercepts, and we can see a maximum, or a relative maximum, and a relative minimum. And Desmos is nice, it gives you these points, or at least it rounded off. So zeros, negative 1.3, then the next one 0, and then 2.5. The max is at negative 0.73. And then the min, or that max value, has a value of 8.536. And then the min is at 1.512 and has a value of negative 25.503. Next one, x squared plus 13x minus x to the fifth. And you can see the 3 intercepts, negative 1.828, 0, 0, 1.967. Max is at 1.3. It has a value of 14.897. And our min is at negative 1.206. It has a value of negative 11.672. The max and mins are what you call turning points. This is where the graph stops and turns around. So if it's going down, it turns around, goes up. If it's going up, it turns around, goes down. Okay. A polynomial has a max amount of turning points that is going to be one less than its degree. Okay. So if a polynomial has degree n, then degree n, then max intercepts is equal to n. So it could have less than n, but that's the max intercepts. Max turning points is equal to n minus 1. So 5 x to the fifth minus x cubed plus 2 has a degree 5. So maximum of real zeros is 5. Maximum of intercepts, because they're the same as real zeros, is 5. Maximum of turning points, 4. Negative 3x to the fourth plus 5x cubed minus x plus 4. Maximum of real zeros is 4. Maximum of x-intercepts is 4. Maximum of turning points is 3. And we can check these two to see what they look like. X to the fifth minus x to the third plus 2. Zoom in on this. We see this would be considered a turning point, and that would be considered a turning point. Right, so this has only 2, it only has 1 x-intercept. So it's not always at the max, but you can have less. Next one, negative 3x to the fourth plus 5x cubed. So then typing it. Again, negative 3x to the fourth plus 5x cubed minus x plus 4. See, that's a turning point, that's a turning point, and that's a turning point. So 3 turning points. Only 2 intercepts, but 3 turning points. Alright, so we can put a lot of this stuff together based on everything we have found so far. We'll add in one other thing that we've kind of already done already. Y-intercept. This is when x equals 0. So 1/2 x squared minus 1. Leading term is even. Positive coefficient. But its end behavior is going up in both directions. If you let x equal 0, here, equal 0, you get negative 1. So 0, negative 1 is your y-intercept. And number of turning points, maximum turning points is just going to be 1. Right? Quadratics always have 1 turning point. It's either going to be a maximum or a minimum, but they're going to be 1 turning point. X to the fifth minus x to the fourth plus x squared plus 3. And behavior, it's odd, positive, so it's going to look like a snake overall. If you plug in x equals 0, you get 0, 3. When the polynomial is written in this standard form and not in factor form, 0, the y-intercept is the easiest thing to get. You just make every x term 0, and wherever's constants left over. Maximum turning points is 4. Then x to the fourth minus 8x cubed plus 10x squared plus x minus 4. And behavior, it's even and positive, so it's up in both directions. If you let x equals 0, you get negative 4, so y-intercept is 0, negative 4. And then the maximum turning points is going to be 3. Alright, so now we're going to get into putting all of this really together. Negative x cubed minus 5x squared. Degree is 3. Right. Leading coefficient is negative, so your end behavior is going to be a downward snake. Something like that. Maximum number of real zeros is going to be 3. Maximum number of turning points is going to be 2. If you let x equals 0, you get 0 out. Every term has 0. So it's going to go through the origin. Right, so now we want to factor this to find the other zeros. So we're going to factor out x squared and a negative sign for that matter. Negative x squared. We're left with x plus 5. So your zeros are going to be 0 with a multiplicity of 2. And it's going to be negative 5 with a multiplicity of 1. Okay, it's going to cross at the negative 5, so it crosses at negative 5, 0. And it's going to touch at the origin. Okay. And so we can take this and do a quick sketch, and then we're going to compare what it looks like. We're going to kind of get an idea of what we know. So 0, 0 is the x-intercept. Negative 5, 0, 1, 2, 3, 4, 5 is the x-intercept. Y-intercept is also 0, 0. And behavior is it's going to be and downwards. We're going to go down this way. Then you go down this way. And it's going to cross at negative 5 and just touch at 0. Okay. So now let's actually graph this. So negative x squared times x plus 5. Much like what we said. So it comes down, back up to the origin, and then comes back down. Do that a little too far. Okay. Getting how far it comes down, right now we only can do this by graphing. For higher polynomials, but there is a way to find it when you get into it. So let's say we have x times x minus 3 times x plus 1 times x minus 4. Now, it's easier to have this as standard form to find the y-intercept, but you don't want to FOIL all this out all the time. Main thing to look at is if all your x's are positive and no coefficients, your highest degree is going to be all of them multiplied together. So this is going to be an x to the 4th. So you're going to have a 4th degree. Oh, eraser. That's what I thought already. 4th degree. And so your leading coefficient is going to be kind of x to the 4th. So it's going to have an end behavior that's up in both directions. Okay. Maximum number of real zeros is going to be 4. Maximum number of turning points is going to be 3. X-intercept, if you let x be 0, you get 0 again. So we get an origin. And this is already factored. So our zeros are 0, 3, negative 1, 4. They all have a multiplicity 1. They all cross. So let's graph this. 0, 0, negative 1, 0, 3, 0, 4, 0. And behaviors up both ways. And they all cross. So this is going to cross here. It's going to cross here, cross here, cross here. So let's see what this actually looks like. X is x minus 3 times x plus 1 times x minus 4. So it doesn't go that low when it crosses into the negative. Maybe a little bit higher though when it's on the positive side in the middle. We just connect everything. So it has a W look to it that crosses the x-axis. So h of x equaling x minus 1 cubed times x plus 2 squared. Okay. We have 5 factors here, so a degree of 5. The real zeros is 5, turning points is 4. Okay. Your leading coefficient is going to be an x to the 5th. So we're going to have an upward snake to it. X-intercept, we can let x equal 0. We'll get -1 a third, 2 squared. -1 to the third is -1. 2 squared is 4. We get -4. So 0 and -4. This is one of the first ones that we have that doesn't have it crossing the origin. Now, number of zeros, you'll have 1, -2. 1 has a multiplicity of 3. -2 has a multiplicity of 2. So the -2 will touch, and the 1 will cross. Okay, so 0, -4. 1, 0, -2, 0. And it's a upward snake to it. So it'll come up, it's going to touch at -2, then it's going to cross at 1. And then we can look at what this graph looks like. Pretty sure I wrote that tonight. X minus 1 cubed, x plus 2 squared. But I may have it, I may not, I may have it too steep here, but it comes out, touches at 2, -2, comes back down, actually goes below your y-intercept, or it comes back up to it, and then it crosses at 1, 0 and keeps going up. Remember, we're just sketching, so we may not have all the details of the graph, just by what we find. Right, so x minus 2 times x squared minus 4x plus 4. Now, this isn't all the way factored. X squared minus 4x plus 2 can factor into x minus 2 squared, which means this whole thing is actually x minus 2 cubed. Okay, so we have a degree 3, so 3 real zeros, 2 turning points. It's, if we multiplied all those x's out, you FOIL them all out, you'll have an x cubed. So the end behavior is going to be upward snake. If you let x equal 0, you get -2 cubed, which is -8. 0, -8 is your y-intercept. So your real zeros, there's only one. That's 2. The multiplicity 3. So 0, -8, 2, 0. It's crossing at 2. And it has an upward snake, so it looks something like this. So x minus 2 cubed. At 0, -8, 2, 0 comes up and crosses. May have sent this over too much. Alright. So 10 m of x equals x cubed minus x squared plus 4x minus 4. Number of zeros is 4. Maximum number of turning points is 3. And behavior, it's an x cubed, so again, it's that snake. If you let x be 0, you get a -4. But we have to factor this to get the 0, so let's do that. The first term, 2 terms, I'm going to pull out x squared. You get x minus 1. Next time I'm going to pull out 4. You get x minus 1. X squared plus 4. X minus 1. Now, x squared plus 4, this is going to give you complex factors, or complex zeros. I should be not square root of 4, but 2i. Okay. So they won't help in determining the graph. But you do have a real 0 of 1. That's a multiplicity of 1 that crosses at 1, 0. So we're going to graph this. Crosses at 1, 0. Crosses at 0, -4. Has a upwards type snake to it. Looks something similar to that. And we'll graph it in here. Again, something similar to one we had. Not much to it based on everything we found, but we can still get a good idea what this sketch looks like. But the last thing in this section is going to be the intermediate volume theorem. This is straightforward, but you see in every math class, even calculus, you'll see this, and they'll be applied a little bit different. But basically, all this is saying is if you have 2 points and one is on the x or positive side and one's on the negative side, then for a polynomial that's continuous, the only way for this to happen, somewhere in between them, there is a 0. Okay. Now, it doesn't mean that, let's do it this way. That there's just going to be 1. You could have a graph that crosses many times, but there will be at least 1 0. Also doesn't mean anything if you have the 2 points that are both positive. You may never cross the x-axis, or you may cross it a few times, but still end up positive. Okay, so this only tells us something is if the values are different. So to do this, all we're going to do is we're going to plug in -5, And then work out the math to see what we get. So we get a negative 125. We get a negative 25, so negative 50. And a positive 40. So you end up, that's negative 10, so end up with negative 135. And then we'll plug in 3. This will give us 27. That'd be 9, 18. That'd be a positive 24. Wait, negative 27. Positive 18. Positive 24. This is going to give us 15. That means there is an intercept between -5 and -3 for x equaling -5 and -3. And so if we graphed it, x cubed plus 2x squared minus ax. We see at -4 there's a 0. -3 is over here, and -5 is over here. I can actually plot these. -5 comma f of -5 down here, and -3 comma f -3 is up here, and 0 is -4, 0. We can do the next one, x cubed plus 2x squared minus ax, -1 and 3. And 3, negative f of 3. Here, f of 3 gives you 0.1, f of -1 gives you 21. And f of 3 gives you 21. So they're both positive, which doesn't tell us anything. You actually see there are zeros in between these two zeros, but it doesn't tell us that, because there doesn't have to be. You could have a straight line that goes directly across. So no information is learned. All right, so that is the end of 3.2. I'll see you in 3.3.